All right. Hello, everybody. Thank you for joining us today. Hope you're having a really great time. Thank you online for the people who will be watching online. My name is Philippe Ozil. I'm joined today with Alba. We will introduce ourselves more formally in the next couple of slides. Today, you're here to learn about Apex and how you can get started with us. Before we start the presentation, we need to make the forward-looking statement. We are a publicly traded company, so please make your purchasing decisions based on what is commercially available in the product and not on any future forward-looking statements we may make. And we will be talking about some of our AI capabilities in the future, so these will be forward-looking statements. Again, I'm Philippe Ozil. I'm a developer advocate on the platform, and I'm joined today by Alba.
Hello, everyone. Thank you so much for joining us today. We are so excited to be here. My name is Alba Rivas. I am a developer advocate at Salesforce, and here you have my contact details in case that you want to ask me anything later. Don't worry about taking pictures because we are sharing a PDF, the PDF of the presentation together with some other resources at the end. So you will have everything.
Yep, documentation, resources, everything will be at the end. All right, so today we have three main topics that we're going to talk about. First is an introduction to the Apex language. We'll see the structure, some of its constraints, some of its capabilities. Then we'll dive into the world of unit testing and how it translates to Apex. And we'll finish with a quick tour of the different developer tools that you can use with Apex. And with that, Alba's going to take it away.
Thank you. So let's start talking about Apex, and let's give an overview to the language and its features. So first of all, we need to understand where Apex sits in the whole set of tools that we have available to create applications on the platform. Basically, there are two ways in which you create apps. One of the ways is through low-code builders, such as Flow, point-and-click declarative functionality, and the other way is through code. In the code realm, we have the Lightning Web Components framework, which is used to create user interfaces with HTML, JavaScript, and CSS. And we also have Apex, which is a language that Salesforce created. It's Salesforce proprietary. It only works on the Salesforce platform, and which is used to implement business logic. Of course, when you are developing apps, you should consider this part in the middle because thanks to low-code integrations, you can get the best from both worlds. But today we are here to talk about Apex, so let's continue doing that. So Apex is a programming language that Salesforce created that is server-side. It is going to execute always in the Salesforce servers, and it is object-oriented, same as Java or C++ or C#. And if you are a developer who already knows another object-oriented language, it's very easy to grasp Apex and make the change. Indeed, I was a Java developer before becoming an Apex developer, and that is the reason I was hired in my first developer company. It is strongly typed. There are all the variables need to have a type that normally map with the different field types that you can have in the objects in the database, plus some specific classes that you can create to create your object-oriented code. And it is also case insensitive, which means that you can write it with uppercase, lowercase, whatever you want, but please don't do it. Please try to agree a naming convention with your developers, the developers of your same project, and try to follow a consistent case sensitivity strategy. So Apex can be used in the platform for many different entry points, and the most common one are Lightning Web Components. With Lightning Web Components, you create the UI, and from your Lightning Web Components, you can invoke your Apex methods and classes. Ideally, or normally, what will happen is that you will be gathering information from some objects that you have in the server and retrieving that information to show those records in your Lightning Web Components and also executing actions on those records through Apex, although there are other ways to do it. Of course, I'm talking about Lightning Web Components, which is our newest front-end technology, but you can also call Apex from Aura components and Visualforce, which are older technologies. Second, it's also very common to find Apex in Apex triggers. Apex triggers are pieces of code that execute when you perform changes in the database. Create operation, update operation, or delete operation, plus some additional ones.
Quick note, I see there are some questions in the room. We'll be taking questions at the end, if you don't mind.
Oh, okay. So a class is basically a file in which you write your code, and the class contains methods which are blocks of code that you can invoke from other classes so that when your Apex code is executing, it starts with the first line that you have in the method. It continues executing the lines sequentially based in your conditional statements and so on. And then normally it returns a value that you can continue using in your code. Okay, no problem. Great. So Apex triggers, these are pieces of code that execute when you perform the ML operations. We also can call Apex from Flow. Remember, low-code integration between, for instance, Flow and Apex is a great idea. It's something great to have because you can get the best from both worlds. You can also create custom REST or SOAP endpoints in Apex, which means that you can expose your methods through an API that can be called and used from an external system. So you could be calling directly your Apex methods that way. And you also use Apex to create asynchronous logic that is going to execute maybe based on a scheduled time, or that is going to execute asynchronously on the backend. Meanwhile, you complete other tasks. Those are batch processes and scheduled processes. And we are in the era of generative AI. We are entering the era of generative AI. And of course, Einstein Copilot and Prompt Builder can invoke Apex. They can use Apex to run the prompts, and also prompt templates can be invoked from Apex.
All right, thank you, Alba. So Alba mentioned the different ways you can call Apex, and I want to go back now to the fundamentals of the language. Just like if you are doing Java or C# or any object-oriented language, everything that you will use in the domain of Apex is an object. Everything inherits from an object, and you'll have various shapes of objects, but at the heart, there's a single thing that is called an object. Now, this object can be null or have a value, and we have different subtypes that are available. We call them primitive types. They're available for everyone. We have a number of types that deal with numbers, integers, decimals, long, double. You'll see that they have different precision grades. Some of them can carry commas, others not. We have also text types, the typical string type, which would help you collect any type of text. And there's another type, which is considered as a text type. That's the ID type. Whenever you manipulate a Salesforce record, they all have an ID, and this ID is a 15 or 18 character identifier, which is unique on the platform to identify a specific record. So you'll be using a lot this ID type when you fetch or retrieve and interact with the different objects that are on the platform. Then you have a bunch of temporal types. I won't go too far in details on these, but you know they exist. And we have a number of other types. The common one is Boolean, true or false. And we have one thing I think which is not so common, that's the blob type. This is what helps you store binary data. So for example, if you're reading a file, the content of this file will be considered binary data. It's going to be a blob. But this is a bit advanced for getting started, just giving you the overall picture. So these are the primitive types. Now, on top of the primitive types, we have something called sObjects. And this is also something that you'll be using quite a lot if you write Apex. sObjects represent a Salesforce object. For example, an account, a contact, any kind of object, whether it's custom or standard. Now, whenever you work with objects as an administrator on the Salesforce platform, you define, of course, the object and the different fields. And this gets translated into sObject classes with fields and attributes that are also mapping to your structure of your database. Here you can see in the example I've shared here, you have an account object that is being created. We populate some of the fields like the name, the type, and even a custom field here, for example, the is active __ C field is actually something that is a custom field. Now, whenever you create custom objects or custom fields, the platform will immediately create those types for you, those sObjects types. So account matches the API name of my standard account object, and the isActive field here is automatically generated whenever I create a custom field on one of my objects. Obviously, you can also have custom objects as well. Now, what is nice about the platform is that it will automatically perform some checks for you so that it always has a coherent state. If you create a new custom object, you automatically gain the associated sObject class. And if you add new fields, the classes are automatically updated to reflect those new fields. However, if you start deleting fields and they're used in Apex, you'll see some errors in the setup menus because you can't remove fields that are being used with code logic. That's an important part to understand in Apex. You cannot break Apex code, it always works. And so you have to think about the operations when you want to tear down something. First, remove the business logic that is using this object or class attributes, and then you can, after that, modify your structure. Now, there are a number of ways you can interact with those sObjects. Whether it's read operation or write operations, there's a whole set of CRUD, create, read, update, delete, typical operations, plus a number of, let's say, less common, like upsert, merge, or delete operations. Now, depending on which one you're using, you'll have different ways to interact with those. The first one we're going to see today is DML, Data Manipulation Language. And that's one of the strong capabilities of the Apex language in the sense that it's really tied to the Salesforce platform. With Apex, you can directly manipulate your data without having to use a client. If you're using Java, you would have to manipulate, for example, database connections. You would have to log in to all of this. But with Apex, you're directly on the platform, so you can directly access your data. And with just a keyword like insert, you can create a new record on a database. So this is an example with insert, how you could insert an account here. But you have the same type of keywords that are available for the other operation, update, delete, etc. So that's how you modify data. Now, on the other side, we have the ability to read data, and there are different options here. The first and most common one is called SOQL, or Salesforce Object Query Language, and this is very similar to SQL. Now, what is really nice again with Apex is that SOQL is directly tied into the language, so you can directly write your SOQL query natively within your code. And you can see here the square brackets allow me to directly write the SOQL query. And again, I don't have to manipulate a database connection. I don't have to worry about the format of the results, converting my rows and cells into an object that are directly provided as account object or whatever it is that you're querying. SOQL works with multiple tables, but it only returns one data type at a time. So you can only query an account at a time or an account tag, etc. You cannot get a return type that mixes accounts, contacts, etc. We have another type of language that we can use to retrieve data, which is called SOSL, and it's using actually another technology behind the scenes. SOSL stands for Salesforce Object Search Language. SOSL allows you, to the difference of SOQL, to mix objects in a return statement. And you can see here in my query that I have here, I'm actually returning a mix of accounts and opportunities in this case. What really helps you differentiate the two types of languages is that SOSL is really based on search on a text string. It's really text-oriented search. And the database that is behind the scene working for SOSL is different from the one that is being used for SOQL. You'll probably use less SOSL and use more SOQL, but I want to give you the full tour. Now, on top of reading and writing data, there are some ways to react programmatically to data being changed on the platform, and these are called triggers. You can have a specific bit of Apex, which is called an Apex trigger, that helps you to react whenever someone changes data on the platform, whether it's through an API, through the user interface. All of this goes down to an Apex trigger. You can create as many Apex triggers as you want, but we recommend generally that you create only one per object type so that it's clear and simple to use. Now, the trigger is built with the trigger keyword, so that's going to be different from a class, but after that, the structure is a bit similar to a class. You have the trigger keyword, and then you name your trigger the way you want. Finally, you specify an object. Here we can create triggers on standard object, custom object, and even sometimes on events, but that's beyond the scope of our talk today. So you specify on which object you're reacting, then you specify an operation. Again, we support the full set of operations, the typical CRUD operations, plus the other operations like upsert, merge. And lastly, another thing that is important, you specify the type of operation you're going to be reacting on. You can do a before or an after here. And what this means, in fact, is you're actually executing your code in a trigger before or after the object is committed to the database. So for example, in the case I have here, in the example I have here, I'm reacting on contact change, and I have a before insert. So before inserting my contact into the database, I will execute this logic. What I did here in this example is that I converted the new contact mailing country to an uppercase string. So if I have France, I would have France in uppercase being written to the database here. And the fact that it's before insert means that I'm changing the data before it's being inserted. So if someone, for example, a user, is editing my contact in the Salesforce user interface, well, before the data is being saved to the database, I'll have the chance to change it before it's been written. I could also do an after write, and I could change data after it's been written so that I could rewrite it or maybe do something else. You don't always have to change the data here. You could be, for example, calling to a third-party system as you're doing a trigger. Now, working with trigger is very powerful, but it's also a bit dangerous in the sense that you have to deal with large scale of data, and we'll see that in the next couple of slides with Alba.
Thank you. So Salesforce works in a multi-tenant environment, which means that the resources that your org is occupying are in a shared environment in which other tenants are also executing their code. That means that a single customer cannot hoard all the resources that are available in that environment. Here we have a representation of that, which is the server would be the building, and you would have this window here, which would be your dedicated space. Because of that, Salesforce created something called governor limits, which are exceptions that are going to be thrown when you try to hoard the limits. Those exceptions can occur per transaction. This is the most common use case. Indeed, here we are seeing the number of queries that are allowed by a single transaction, 100, or for instance, the number of DML statements that are allowed in a single transaction, 150. But there are other limits that apply per day. The ones that you have to take specially into account in your Apex code are governor limits. Governor limits cannot be catched. It's an exception that is going to be thrown and is going to arrive to the end user, and that is something that we really need to take care of as Salesforce developers. For some people, this is like a problem or something that they don't like, but I can tell you that governor limits makes you a better developer because you need to write much more performant code, and you need to really invest time in checking that and writing a code that is cleaner. And they are the same for all customers. There's no way to get rid of governor limits.
Yes, thanks. So another thing that is specific to the Apex language on top of limits is the security model. Because Salesforce is running Apex on its server, it has to enforce the security sharing model. And there's different ways to specify security access to your objects, to your records, and even to your fields within the record. And so whenever you write Apex code, you retrieve data with SOQL or with other means, you have to make sure that you don't break the security and the trust between the users, so that users don't see data they're not allowed to see, and you can't process data that you're not supposed to see. So we have a number of security mechanisms that are put in place when you write Apex code to ensure that you respect the security model. Sometimes it's perfectly fine to write code that doesn't really need or uses the security model, but most of the time you want to make sure that you don't break this. By default, Apex runs in what we call the system mode. The system can see everything, can modify everything. This is fine for things like batch tasks that are happening behind the scenes, but when you have something that is closer to your user interface, well, you want to be very careful about the security. To do that, we have a number of mechanisms we can apply. The first one is the execution mode. Execution mode is specified at the top of the class. Sorry, actually, it's the opposite. The sharing keyword and then the execution mode. You can see here in the code sample we have specified the sharing keyword on top of our class. This class is using with sharing. This means that we'll be enforcing the sharing security model. And later on, we have something called the execution mode. For example, in our query, we have with user mode. That means that we're respecting the current user permissions. And same thing for the DML statement later on, we have update as user. This means that we're respecting the current user perspective, we're respecting their access rights. And if, for example, we were trying to modify a field that they don't have access to, we will be seeing errors at this point. That is how you enforce the security model when you write Apex code. Now we'll be taking a look at how you can test all of this.
So in Apex, it is required to have a 75% coverage of your production code with tests. And that is why a good approach is to think about tests and write them at the same time as you are writing your production code. Because if not, it can happen that you have written 1,000 lines of production code and then you need to spend 2 weeks creating tests. So consider that from the beginning. Even it is a great approach to start writing tests before writing the production code. That is called a TDD, test-driven development. So test, just make sure that your production code is working as expected. And they are normally executed in an automated way with continuous integrations and continuous deployment jobs so that you can detect bugs earlier in the development process, but they are also executed when you do production deployments. This is, you cannot deploy if your tests are not passing and they are not covering the 75% of your code. In Apex, tests need to run on the platform. There's no way to run those tests locally. You need to deploy them and then run them there. And they don't see the data that you have in your org. This is, as part of your test, you need to create your test data. If your test is going to check that a method that is working with accounts is having special behaviors, you need to create those accounts as part of your data creation section in your unit test. And something important here is that regarding code coverage, quantity is not the same as quality. I've been in projects in which I've seen there was a 75, even more coverage for the production code, but where unit tests were not really testing anything. So it's really important for getting the real benefits of unit testing, being able to detect bugs early and being able to incorporate features with confidence. It's really important to create proper unit tests that really have assertions and that are testing what your code is expecting to do. This is a typical unit test, but you can see in the right. It is a regular method, but that we annotate with the @isTest annotation. And the test is normally going to have 3 parts. It's going to have the given part, which is the part in which you create your test data, the data that your method is going to work on. Then we have the when section, in which we are going to call the tested method. And then we have the then part, in which we will be making our assertions. It is a best practice to enclose your tested method call between test.startTest and test.stopTest, because these 2 methods, what they are going to do is to first reset the governor limit count so that it starts right before calling your method. And second, it's going to synchronize asynchronous code. So if you are calling a method that is executing asynchronously or a batch process, you need to do it between start test and stop test. And that is a best practice. The other thing that I always recommend regarding unit testing is to use the given, when, then pattern. This is not something that I have invented myself. It was created by Martin Fowler, which is an eminence, like a celebrity in the world of software development. And I find it really useful to really design my test beforehand and think in the structure that it needs to have. And also, this is a very advanced topic, mocking, but it is a great idea to decouple your dependencies with mocking. This is a concept that is going to decouple the code that is being tested when you are executing it in unit test execution time from its dependencies, so that you only test, you only focus on the code that belongs to your method and not in any dependencies. And if you are interested, I will give you some information regarding this in the resources. And finally, let's take a look. We're taking... Oh yeah, sorry. And thank you very much, because I actually forgot. Thank you very much. So traditionally, the way of doing assertions in Apex code was through a class called system that had a method called assert, assert equals, assert not equals. That class is older, but last year we released a new class which is called assert. And this class is more convenient because it's going to give you more meaningful messages, and it also includes a couple more ways in which you can make your assertions. For instance, it includes an assert.fail method that is very useful for testing exceptions. Thank you. And yeah, we're going to continue with developer tools. We are going to take a look at the developer tooling that you can use and that you should be using to develop Apex code on the Salesforce platform. So this is a developer console. I'm sure that many people here have been using the developer console. It was created a long time ago, and it's been great for some time, but this is not anymore the recommended way to develop code on the Salesforce platform. We are not maintaining it, and an end of life hasn't been announced yet, but I think that will happen at some point. So please don't use the developer console, because there are like much more efficient ways to develop apps on the platform, and that I'm going to give you a much more pleasant developer experience. The recommended way to do that is with this setup. So this is your org, okay? And we are going to interact with the org with the Salesforce CLI. The Salesforce CLI is a command line interface executable that you install in your machine, and with which you can type commands to work with your org data, your org metadata, and it can do multiple things, like work with packages, it can run your tests, and many, many more things. And then the idea is that you work on your code in a local copy of the code that you write and that you manage through one of the Salesforce IDEs. There are two. So VS Code is the desktop IDE, and we have a web-based version which is called Code Builder. Code Builder is available in Professional Edition, Enterprise Edition, and Unlimited Edition orgs. And you need to go to Setup, find it there, activate it. I think you need to install it actually, and then it pops up as an app that you can use to develop in multiple orgs. So you install it in one org, but from Code Builder you connect to all the orgs in which you have projects. And then in those IDs, we recommend using those IDs actually, because we have a set of extensions that we have created specially for Salesforce developers so they can become more productive. Also, there are other, although there are other IDs available out there that people are also using. So those extensions come pre-installed with Code Builder, and you need to install them in VS Code, but it's just one click. And one of those extensions is very useful for creating Apex code and debugging it. And that tool is the Apex Replay Debugger. Actually, there are two debuggers. The first one is the Apex Interactive Debugger, but I'm not going to focus on that one because it's a paid feature for ISVs only. And the second one is the Apex Replay Debugger, which is completely free. It comes installed with extensions, and everyone can use it. And this is very, very useful because it allows you to add breakpoints, variables, watch expression, and more. And we are going to take a look at that in a second in a demo. And finally, something that you can use that is very new is our Einstein for Developers extension, which is an assistant that will help you generate code. And initially, it was released with a feature that allows you to open a sidebar and ask Einstein, which is a large language model under the scenes, which code you want to generate, and it's going to give you some responses that you can use in your code. But it has now incorporated some more functionality, which is really interesting. One of the functionality is the ability to generate tests automatically right by clicking a button, and the other functionality is code auto-completion suggestions. So now, well, we're going to skip that because I think we are doing a little bit bad on time, and I will explain it as part of the demo. So now we are going to take a look at the demo. Okay, so, oh, I forgot to open this. Okay. So this is Code Builder. This is our web-based IDE in which we have already pulled some code from one of our orgs. And the org is this one that we have here. And in this org, I have deployed an app called Greenhouse. You saw how I was able to open the org to which I'm connected by clicking in this button, which is very convenient. I can also take a look at the different orgs with which I'm authorized this way, and the one that is bound to the project that I'm taking a look at is this one. I can also take a look at the metadata. Oh, okay. Not sure why it's not working here, but I should be able to see, oh, because it's this icon. Okay, there it is. Yeah, so here I'm able to take a look at the Apex classes that are in my org, and I'm able to retrieve those Apex classes. There are a lot of capabilities here that allow you to work with your org through the Salesforce CLI, so you don't have to remember commands. So this is Greenhouse, our one of our sample apps, which code is available in GitHub. And in Greenhouse, it's supposedly real estate agency app. Is a fictitious use case in which real estate agents can come here and take a look at the properties that are available, and they can navigate to the properties and so on. So this component that we see here is a Lightning Web component from which we are calling Apex. Why? Because we need data that is stored in Salesforce servers, and we cannot compute that in Lightning Web Components directly. Well, there is a way to do that now with GraphQL, but we are going to assume that we cannot use GraphQL in our use case. So the way in which we would do that is by creating a method that we expose with the auto-enabled annotation so it can be used from a Lightning Web component. And this method is receiving some parameters that have specific type. Remember, we mentioned that Apex is strongly typed, and this method is doing some cleanup on those parameters, and then it is executing a SQL query to retrieve the results filtered by the parameters that were provided, which are the parameters that I selected in my filters. It's also applying pagination thanks to this offset keyword, and it's like computing the properties that we need to return to the Lightning Web component, to the front end, so the Lightning Web component can render the properties and show them to you. Then for this method, we have a test. that we can find here on the test class. In that test, we have the given part in which we are creating some properties. Remember, our test won't see the data that exists in the org. Then I'm calling the testing method, and then I'm doing some assertions to check that the result is the one that I expect. That under these conditions, my method is returning these records. The test could be a little bit better because we could be checking like which specific records it is returning, but well, it's testing the method in some way. So something that we can do here is to run the test, or we can always also debug it. So remember I mentioned the Apex Replay Debugger? So when you click on that debug button, which is there because of the extensions, behind the scenes, you are launching the Apex Replay Debugger. The Apex Replay Debugger is retrieving the logs, the debug logs that were generated when this test was executed, and it's replaying them. So you can add breakpoints. You can add breakpoints in your code so that it stops there. And so you can inspect the variables. The variables are going to appear here, but you can also position your mouse over the variable and take a look at what it contains. So this is very convenient. And because from here we are calling, well, this is a breakpoint that was in the production code. And of course, I can also add breakpoints in the test code. And now my colleague Philip is going to continue talking about Einstein.
Thank you. So we saw the traditional tools, and I want to focus just a couple more minutes on the ones that are very new, the AI capabilities. So everybody can now have a go with Einstein, and we have a number of features that Einstein supports. The first one is the most commonly used, I would say, that's the text-based prompts. So I have a little prompt in here that I can use, and I'll just copy paste it to save a bit of time. I'm going to ask Einstein to write a method that selects property records ordered by name. And so the way it works is that you have the Einstein sidebar here, and you can ask it questions. So I'm going to copy paste my text prompt here. And when I click on ask, I'm going to integrate Einstein generative AI, and it will return for me some source code that it works, and it's actually fulfilling the prompt. Now, what's really powerful, unlike any other generative AI that you have on the market, is that Einstein is grounded. It knows about our org context. For example, it knows what the property __C is because it knows whether our metadata contains an object that represents a property. And it knows about its capabilities, it knows what are different fields, and it's able to generate test code for us. Now, Einstein works in a different number of ways. This is the first way you can interact with it, the sidebar, but there are also other means that you can use to interact with code. The other thing is, for example, if I have this method here called getPicture, I can right-click anywhere on this method, and I can ask Einstein to generate test code for this method. So it will send the code of this method to our large language model, and it will compute. In a couple seconds, we'll get a suggested test class for this, if it goes well. Okay, looks like it didn't work this time. Let me try again. Last time we had a little glitch there. I'm going to try again. So again, right-click on the class, ask it to generate a test. And sometimes I'm really impressed by the quality of these. This is not a simple test to write because in this particular method, here, we have the code. This is not a simple test to write because we're interacting with some 1,000 attachment and it needs a couple of lines of code. So here, for example, I could take this and it generated for me some documents and it's testing that I have my documents when I call my method. It's following the given when then pattern. So that's one of the main capabilities for Einstein, but there are many more to learn. Soon you'll be able to access it with Lightning Web Components as well. For now, it's only Apex, but we're going to expand the scope of this great tool. With that, I'm going to go back to the slides and we're going to finish our presentation. We saw the different capabilities of the Apex language. We saw what really makes it unique, the way it is coupled with the platform. We saw some of its key features, the fact that it's object-oriented, case-insensitive, server-side. We saw also things like the limits, the performance that you need to take into account when you write Apex code. You've learned the best practices, such as writing test code as you write business logic. Remember that there is a minimum code coverage that is required when you want to deploy Apex to production. And finally, we give you a brief overview of the different Einstein AI features that are available right now. Now, to wrap it up, these are the resources that I want to share today with you all. There's a QR code, and for those of you who are watching online, you'll be able to get the links so you can directly access those. We will also be showing this after a couple of slides with the questions as well. So if you haven't time, we will show again the QR code there. That's it. I want to thank you all for watching, especially the people who are watching online. And with that, we're going to take a few questions and share again the resources. Before I do that, I just want to share one thing. You can give us your feedback. If you liked our session, make sure you read it. You can use the Salesforce event app to provide feedback on our session, and you get a chance to win a voucher for some coffee.